It's more to do with the phraseology of this question. By that I mean they're asking you to find the partial derivative with respect to x. And here they're asking you to find the partial derivative with respect to y. If you think about that surface that I was talking about, imagine this is the surface that represented that guy. If you take a slice of that shape and you do it in the x direction, then you do it in the y direction, what you're basically doing is you're drawing a line something like this, and then it's cutting that shape. And can you imagine if you cut that shape, you'd end up with this fella. And what you're trying to do is find the derivative at that point. So what they're really saying here is just find these two guys' partial derivatives, and then plug in that x and that y to the answer. So let's look at the process of how you would find these two different partial derivatives. Now, there are two ways to do this guy. Both end up being the same answer, but there are two ways to do it. You could think of this as being f, you can think of this as being g. And if you wanted to find the partial derivative, let's say we do this one, then this would become the quotient rule. But a special version, partial derivative version of the quotient rule. The top is 94. Now, since we're differentiating with respect to x, this fella, instead of really being called f dash x, truly should have been called f subscript x, right? The partial derivative with respect to x is 0. The bottom guy is 7 plus x squared plus y squared. And instead of really calling it g dash, you see I'm going to call it the partial derivative, which is the equivalent to that. But that's a number, and that's considered the number, so all you get out of that guy is this. So you can, if you do it this way at least, you can say f dashed, which is 0, times g. I don't even need to write g down because I'm going to multiply it by 0. Take away f times g dashed, and the whole thing is going to be over 7 plus x squared plus y squared. Now that gets you nothing. This guy gets you 188 over that guy. Now we're going to evaluate this at the point, I believe it was the point 23. So can you imagine I found that guy goes there, 7 plus this guy, and then I'm just going to assume that if I can get back to my guy, that fella there simply just turns into that ugly number I had a minute ago. Now I'm frantically trying to find the stop sharing screen. Oh, it's not shops. That's why. Here we go. Right, did that make sense? Let's go back and check what the answer is. Right, so one of those answers is negative 47, and the other one of those answers is negative 141. Right. Now, if you're doing something in the x direction, right, so you're doing a slice that's parallel to the x-axis, can you see what you're doing there?